Today, we're diving into a really fascinating scientific study, one that looks at a potential new therapy for a major cause of vision loss. And honestly, it sounds a little bit like science fiction, but this is real research. So let's get right into it. The big question at the heart of this whole thing is pretty bold. Can we use tiny, targeted electrical currents to actually help people with vision loss see better? It's a huge question, and it's exactly what these scientists wanted to investigate for a condition that affects millions of people.
So to really understand the potential solution here, we first have to get a solid grasp of the problem itself, something called macular degeneration.
Now, this isn't just about your vision getting a little blurry. Think of the macula as the high-definition camera of your retina. It's what gives you that sharp, central vision you need for reading a book, recognizing a friend's face, all those fine details. So when it gets damaged, usually because of age, the very center of your world can start to blur or get distorted, or in some cases, even disappear.
And this condition really comes in two main forms. The dry type is the one you see most often, and it tends to progress pretty slowly over time. But then there's the wet form. It's less common, but it's way more aggressive because it's caused by these leaky blood vessels that can cause rapid damage. And what's really important here is that this study looked at patients with both types.
Okay, so now that we're clear on the problem, let's move on to the experiment itself and see how these researchers decided to tackle this challenge with a pretty new therapeutic idea. You have to understand, this was what's called an exploratory study. That means it was pretty small, really designed to just see if there was a signal, something worth looking into more deeply. They had 17 patients, all in that typical age range for this condition, from 67 all the way up to 95, and in total, they treated and kept a close eye on 25 eyes with the dry form of macular degeneration and 6 eyes with that more severe wet form.
So what did this treatment actually look like? Well, this picture from the study shows you just how non-invasive it is. You see, the electrodes are placed in a kind of moistened fabric right over the patient's closed eyelids. It's a method they call transpalpebral stimulation. No needles, no surgery, just a gentle current from the outside.
Let's break down the whole process. So, like we just saw, electrodes go over the closed eyes. Then, for about 35 minutes, a machine delivers these really gentle, super low-intensity electrical pulses. This wasn't just a one-time thing either. Patients got this treatment once a week for 3 months. And, critically, the researchers measured their vision before and after every single session to track any changes with precision.
And that brings us to the really big question. What is this electrical current actually doing to the cells in the eye? I mean, how is this supposed to work? Let's get into the science behind it.
You know, the easiest way to think about what researchers believe is happening is to imagine giving the struggling cells in the retina a gentle push. The cells that are damaged by macular degeneration are under a lot of stress, and the theory is that this microcurrent acts like a kind of bioelectrical pep talk, just encouraging them to work a little better.
So how does this gentle push actually work on a biological level? Well, the study suggests a few things. First, it could be boosting the production of something called ATP, which is basically the energy molecule for all of our cells. It might also encourage the cells to release their own natural protective compounds, calm down harmful inflammation, and maybe even increase crucial blood flow to the retina. And one of the most fascinating ideas is how it might be fighting that inflammation.
The researchers talk about something called a resonance effect, and the analogy they use is pretty cool. Think about how a singer can hit a very specific note and shatter a crystal glass. The idea here is similar. The specific frequencies of the microcurrent might resonate with the molecular bonds that hold inflammatory stuff together, essentially helping to break it apart on a microscopic level. It's a really targeted way of thinking about fighting inflammation.
Okay, so we've got the problem, we've got the patients, and we've got the theory. I think it's time to get to the most important part. Let's look at the results and finally answer the question, did any of this actually work? Did these patients' vision get any better?
So for the 25 eyes with dry AMD, just over half, 52%, actually showed improvement, and often it was a pretty significant improvement. Now, for a condition that has very few treatment options, that's a result that makes you sit up and pay attention. About a quarter did worsen slightly, and the rest didn't see any change.
But then we look at the results for the wet AMD group, and they were even more striking. An incredible 83%, that's 5 out of the 6 eyes in that group, improved. The other eye saw no change. And here's the key takeaway. Not a single eye in this more severe group got worse. These initial results are definitely attention-grabbing, right? Especially for the wet AMD group. But what do they really mean for the future of this kind of treatment? Let's get into the conclusion. You know, the researchers themselves give us the perfect balanced perspective right in their conclusion. They say the results indicate a potential efficacy, which means the treatment might be effective, but they immediately follow that up with a really critical warning. The study had no control arm, and because of that, these promising results have to be treated with a lot of caution.
So what is this crucial missing piece? Well, in science, a control group is absolutely essential to prove something really works. It means you have a whole separate group of patients who go through the exact same motions, they wear the pads, they sit there for 35 minutes, but they get a fake or sham treatment with no actual microcurrent. By comparing the real group to the sham group, scientists can prove that the improvements were caused by the treatment itself and not just by the placebo effect. This study didn't have that, which is why it's a very exciting but also very preliminary finding.
So, while this is just a first step, it raises a really powerful question. Could a simple, non-invasive therapy like this one day become a standard way to slow down or even reverse vision loss? We absolutely need more research to know for sure, but this study opens a very, very exciting door. And it makes you wonder, what other age-related conditions could be treated with this kind of technology in the future?